Have you ever been at a stoplight and glanced over and see a shiny, loud muscle car next to you and mutter, among other things we won't say here, that thing must be spewing out pollution by the bucket load? Well, we all breathe the same air and we should be concerned if someone is unduly polluting it. Before berating that muscle car owner, consider this. In 2004, California Assemblywoman Sally J. Lieber penned Assembly Bill AB 2683, which requires that cars built after 1975 pass a rigorous smog inspection, and the permissible limits on emissions are very low and very difficult to meet. I am one of those muscle car owners, but my vintage car has a unique problem. It is new enough, a 1979, that it has to pass inspection. But it is old enough that it does not have an onboard diagnostics or OBD computer system that were rolled out in 1980 to keep the engine running clean. In 1979, all the controls are mechanical. If something goes out of adjustment, I would not know it until I fail a test and drew the eye of the law. This talk will describe a solution to this predicament: how to measure in real time and optimize for the lowest emissions the air-fuel ratio of a pre-OBD vehicle. It turns out that some of us motorheads take emissions compliance seriously. Now, I recently swapped a new engine into my car, implemented a full suite of emissions controls, and demonstrated compliant emissions to the satisfaction of the California Air Resource Board referee. The key to this success is understanding something called stoichiometry, the ideal air-fuel ratio, measuring the car's actual ratio under real driving conditions, and finally, adjusting that ratio for the lowest emissions. But first, a little chemistry lesson. A stoichiometric ratio means that there's an oxygen molecule for every hydrocarbon, or HC, molecule burned. For gasoline, that ratio is 14.7 parts air to 1 part fuel. As Marcus Hilgendorf explains in his 2004 paper for Topics and Catalysts, I'm sure you all read and subscribe to that, if there's not enough oxygen, a rich mixture, some HCs leave the tailpipe unburned as smog. On the other hand, if the ratio is too lean, too much air and not enough fuel, the mixture burns very hot, and nitrogen forms with oxygen and forms poisonous nitrous oxides, or NOx. Among other unpleasant things, NOx turns the air brown. A stoichiometric ratio is what we want, but is the car achieving that? We'll have to measure it. Enter the oxygen sensor. Jasansky's 2006 article in Material Science Poland gives a crisp description of how the wideband oxygen sensor works. By comparing the exhaust stream to a surrounding atmosphere, this device gives a signal that is proportional to the car's air-fuel ratio. All we need to do is install one of these little sensors in the car's exhaust stream, and then use a simple, or at least simple for 2019, maybe not so simple for 1979 when my car was built, computer to convert the sensor's reading into the air-fuel ratio and display it. With that done, we know the actual ratio under real driving conditions, but what if it is not ideal? We might need to get our hands dirty. Recall in 1979, all the controls are mechanical. The device that sets the air-fuel ratio is the carburetor. Inside the carburetor are metering rods that insert into a jet and control the fuel that flows into the engine. We have two knobs that we can adjust to get that 14.7 ratio we desire. If we're way off, we can change the rods for a thinner one, allowing more fuel, or a thicker one, allowing less fuel. Once we're in the ballpark and we got the right rod, we can make fine adjustments to the height of the metering rod, where this tapered section enters the jet in very fine increments and nail that 14.7 ratio. Applying some 21st century technology to my awkward in-between years car makes it run as clean as a much newer car. By understanding the chemistry of stoichiometry, how to measure it, and then to adjust it, these cars can run clean and we can all breathe a little easier. This all means, of course, that when you glance over at me at a stoplight, you might mutter something you can say in front of the kids, and maybe even give me a thumbs up.